Control X has the ability to capture data live within the software. You can use any kind of commercial scanner available. There's plugins for all of the major ones, and you can see here we're using the Hexagon AS1 scanner. Simply select the LiveCapture option and then start scanning. Once you've connected the device, it's very, very simple to scan directly into the software. Along with LiveCapture, you can do live align, live geometry, and even using the probing function if you have a scanner that also has a probe, like this Hexagon arm here. So the first few scans, I'm just shining the laser line over the part, trying to capture as much of that geometry as I can. You can see that the preview of whatever I capture is shown in red, and when I finish that particular scan or that particular pass, it will turn blue to show me what I've captured. So I have live feedback as I'm scanning. Again, it's called LiveCapture. You get to see it happen in real time on the screen inside Control X. Another benefit, especially with scanning, is that the view automatically updates. So as I move around and continue to scan, if I start another scan, the view will also change, so it can update as I go. I can take this scan data in as many passes as I decide. This is an example of the view moving to allow me to see the exact area I am trying to scan. And I just need to position the arm and the scanner to be in that recommended zone so I can actually capture the data correctly. Now, scanning parts like this can sometimes be tricky, especially because you can't get the underside of the part when it's on the table like that. Unless you mount it on some kind of granite table where you can stand it up and off the flat surface, you may have to take more than one scan. That's not a problem, because inside Control X you can also do alignments between all of these different scan datas. Having the new area that you scan highlighted in red is really helpful to show you exactly where you're currently scanning and where you have left to scan. And once it's completed, it goes blue, and then you can fill in the rest of the holes or the gaps with the new scan, which is highlighted in red. The benefits of having a hexagon arm to scan this kind of part is that you don't need to use any kind of tracking targets, dots, or anything like that. The arm knows exactly the position of the scanner at all times. So as long as the part doesn't move, you can scan it without having to do any kind of part preparation. Once you've got your part successfully scanned, simply delete any unwanted data. In this case it would be the table. Here I'm doing a global and fine alignment between all of the different scan passes I created. Very, very easy to do. Just select the one that you want to keep as reference, select the rest of them as moving, and then perform the global and fine alignment. Now, since the part didn't move and the scan was all scanned in kind of one session, the global and final alignment is really just to tighten up all of the data, and then after that we're going to do a combine or a merge of all of these scans. But first we need to capture the underside of the part, so I'm going to flip it over and do a second scan. The global and final alignment is done. Now I can turn off that data or remove the unwanted data now, depending on what I prefer to do in what order. You are completely in control when you're using the software. It's up to you what you do. So yes, I'm removing the unwanted data here, which is basically just the table. This could be removed prior to even starting the scan if you wanted to set a clipping plane. It's entirely up to you. I left it because it's very easy to remove the base with just a couple of clicks. I'm reviewing the data to make sure that there's any holes that there are. I can go and add or focus on them in this second scan. I'm going to merge all of this data together, so instead of having lots of different scan passes, I have one scan that I can use for this next step. Now that I have just one scan of this first orientation of the part, I can go back into the LiveCapture command, and since the device is already connected, position the part where I want it, and then repeat the same process again. This time I'm making a focus to capture that top surface, which was the bottom surface on the first one, and you can see there that it was in probing mode, because you can do both, but I'm going to switch it to scan mode and continue to scan the part. The big thing between scanning one side and the other is you do want to make sure that there is some overlap, so that when you align it in this later step coming up, it is very easy, and when you do your picked points or automatically align the two datas, having overlap will be really, really beneficial so that you can actually align the data. The benefit of the arm is that you can really move wherever you need to get into those cracks and crevices of the scan. You can just manipulate the arm to get the scanner positioned exactly where you need it to capture wherever areas you're trying to capture. You can see I can get all the way into those through holes as well on the side. I should also note that whenever you have a part like this, you really want to be careful not to knock it, because if you do knock it, you'll have to stop the scan and potentially start another scan. So trying to keep it as still as possible, typically using some kind of rigid alignment fixture will really help. In a pinch, I've used things like blue tack to hold the part in place if it's potentially unstable. Once I'm happy with the scan that I've done in the second one, we're just going to repeat the same step that we did earlier. When we stop this live capture session, we then review the data that we've captured. So this will be scan 2, remove any unwanted data, and then merge and perform a global and fine alignment so all of that data is nice and aligned together, and then merge it together, and then what we'll do is a final merge between scan 1 and scan 2. Now this will be a different kind of alignment. Instead of using the global and fine, we do need to actually orient the two scans together, so we'll be using the picked points option. Now we are going to combine all of the scan data for scan 2. So we'll end up with 2 scans. Scan 1, which is all neatly packaged together, and then we're going to do the same thing for scan 2, and then we move on to our alignment step. Now that we have the 2 scans completed and merged, you can see that they aren't quite aligned right now, so we're going to do a different kind of alignment, which is the picked points. So I select my reference, which is scan 1, and my moving, which is going to be scan 2, and I position the 2 parts so that they're roughly in the same orientation, and then I just start picking points. Now you don't have to be super accurate with this. This is really just giving the algorithm in the background a starting point to then do essentially a global and fine alignment where it makes it really tight and neat and actually positions the 2 scans in the same orientation. You only need to pick 3 points. You can pick more if you want to, but 3 is the minimum you need to pick. On the left, you have the preview of how those points line up, and on the right, you have obviously your moving data and your reference data, so you can see exactly where or what you want to pick. Now that the 2 scans are positioned, we can do a global and fine alignment again, just to make sure everything is neat and tidy before doing a merge. And now we're going to do our final merge. We can pick any kind of how we want it. We can even do an ultra high definition mesh construction if we want to. We can control how much noise we remove if the scan data was potentially noisy or messy. And then we'll get 1 scan. Now, as you can see, inside Control X, I already have the CAD imported, so we can actually just then start our alignment between the scan data and the CAD data. And if we already had an inspection routine created, which we can definitely do, it would just then inspect the part automatically for us. If we didn't have an inspection routine set up, we can set it up ourselves. Since I already have an inspection routine set up, I've just hit refresh. It automatically aligns the part, does a best fit, adds my color map that I've selected, adds my 2D compare, and all of the dimensions that I've taken, which I've deemed important and critical. And you can see very quickly the part is a little bit out of tolerance in some areas, but the actual dimensions that we've taken are also mostly within tolerance as well. Once we have finished our inspection report, finished our inspection program, we can then export a report. We have full control over what we want to be included. We can add or remove certain elements to it, and then once we're done, we just hit generate, and it's going to give us our report preview. We can then save this out as a PDF, an XML file, an Excel file, or whatever you may choose to do. Now, if you have multiple parts and you're going to be scanning lots and lots of parts, you can just continue scanning and then actually do a batch process. So use the automation tools inside Control X to essentially repeat this process again and again and again and export all of those reports that you want. So once I've reviewed my report, I can save it out and I can move on to my next project.